By the end of this video, you know when to use synthetic division. You know how it works and how to use it. You also know specific situations and common mistakes. Okay, first, what is synthetic division? Synthetic division is a quick method or like a shortcut to divide polynomials. For example, you got a polynomial x2 plus 3x plus 2, and you want to divide it by x plus 1. Well, how would you do that, right? You can't just do it how you normally would with other numbers like 3 divided by 6 or 2 divided by 1. You need to use long division, but long division is pretty slow. So that's when you use synthetic division if you want to go faster. So here's how you would set this up. How you would set this division up with synthetic division. Now first, you draw some lines, okay? So it could be like that, or so it could be like that, or maybe like to draw like that. Now on this top line, you're going to write the coefficients. So this would be 1, 3, and 2. 1, 3, and 2. In this slot over here, in front of this thingy, you're going to write, well, this part, specifically the 1. But not just the 1, it has to be in x minus c form. Now to put x plus 1 in this form, you can rewrite it as x minus negative 1. These are equal, okay, same thing. So we're going to take negative 1. If that sounded confusing, just follow this rule. Just flip the sign here. So it's plus 1, we're going to write negative 1 here. Now draw a second line. I'll give it more space. Draw a second line. Here's how to actually do it. Bring down this first number. So 1, we're going to bring it down here. Now you multiply this outside number by the number you just brought down. So what's 1 times negative 1? Well, it's negative 1. Write it in this middle row up here under the second number. So this becomes very, very natural, very, very fast as soon as you start doing some practice. So just try and follow as best as you can and then go and do some practice. I'll leave some free worksheet in the description. Go and do it. It'll become very natural. Now let's continue. What do you do here? Well, you add these two numbers. You add them. So what's 3 plus negative 1? Well, you get 2. Now you repeat. What's negative 1 times 2? Well, negative 2. You write it again, middle row, the next slot. And then you add these. You add the vertical numbers here. 2 plus negative 2, you get 0. Okay, cool, we just did all that. But what does any of this mean? What do these numbers down here mean? Well, this is the quotient. So this is your answer pretty much. Here, this means x plus 2. And this number here, in this corner, in this bottom right corner, it's always the remainder. This is always the remainder. That means there's 0 remainder. So that means this polynomial up here, when you divide it by x plus 1, you get x plus 2 with no remainder. Now, when do you use it? You use it when you're dividing a polynomial by a linear factor. So what's a linear factor? Let's say you had a polynomial. I'm just going to write px. And you want to divide it by x plus 2. Well, then you can use synthetic division. But this is a linear factor. If you wanted to divide it by, for example, x2 plus 2x minus 1, this is not a linear factor. If you drew it on a graph, it would be a parabola, not a line, so it's not linear. It has a square, that's why. It has an exponent. So you're meant to use it when there's a polynomial and you divide it by a linear factor. Here's some common mistakes. Don't mix up signs. Obviously, you're not meant to, but it becomes easier to mix up signs, especially let's say you got some numbers going on here, like 5, got thing. When you're doing all the stuff down here, I mess up on this. I forget the negative sometimes. Take it slow, check your answers. Another mistake is incorrectly setting up the divisor. Now, what does this mean? Let's go back to our other example. You're dividing a thingy and you're dividing it by x plus 2, for example. When you are setting up the synthetic division diagram, make sure you're taking the divisor correctly. Remember, just take the opposite sign. That's the easiest way to remember it. It's plus 2, then take it as negative 2. And then you can go on with your division. Now, how about higher degree polynomials? So cubic polynomials or even higher. So let's take 2x3 plus 4x2 minus 5x plus 3. And you want to divide it by, let's say, x minus 2. How would you do that? Well, it's the exact same. You don't have to stress yourself with any extra information because it's the same process. Let's set up the divisor. Take a moment to think. What's the divisor? What goes here? Well, it's 2. Now take the coefficients. So 2, 4, negative 5, and 3. 2, 4, negative 5, 3. Now I'm going to go slowly here so you can follow it. Bring down this number. 2. 2 times 2. Well, it's 4. So let's write the 4 in the next slot. Now we add the up and down numbers. 8. 2 times 8. We just repeat. So 2 times 8, 16. Add negative 5 and 16. You get 11. 22 and add these 25. This is the quotient. This is the remainder. So this reads as 2. Let's write it up here. This reads as 2x2 plus 8x plus 11 plus the remainder. Now, how do you write a remainder? In long division, let's say you got your long division thingy, for example. If the remainder is, let's say, 1, you will write it as remainder over this outside number. So 1 over 2. Same thing here. I know I explained that very quickly, but I would assume that you know that because that's long division. If you don't, it's okay. You write it as 2x squared plus 8x plus 11 plus 25 over x minus 2. X minus 2 is this thing here. Now here's a specific situation like the kind I was talking about at the start of the video. What if there's no like x? What if it skips power? What does that mean? Let's say you have x3 minus 2x2 minus 5. And you divide it by x minus 3. You might have noticed there's no x value, just x to the power 1. Do you do it the same way? You don't. Let's set it up. So you draw your lines. What goes on the outside? It would be positive 3. Now you set up the coefficients. So you have 1. So 1. Negative 2. Remember the negatives. Now here, you don't just go ahead and write negative 5. You don't do that. You actually have to write 0 to make up for this missing x. Because you could also write this polynomial as x3 minus 2x2 plus 0x minus 5. So we write it as 0 here. And then the negative 5. Well, now we can go through and solve it. So as you solve it, it's a good tip to make sure that you're getting everything right. And that's obvious, I know. But synthetic division, it's a fast thing. You use it to be quick. So when you're being quick, obviously you'll make mistakes more. So just put a little more conscious thought into remembering your signs, making sure your arithmetic is correct. Now, how would we write this as like, like a thing? How do you write that? This would be x2 plus x. So remember, these are the new coefficients. So it would be 1, x1 plus 3. Now, this is the remainder. you write it as 4 over whatever this thing is here, x minus 3. That is the answer. If you want practice problems for what I covered today, they're in my Discord, they're in the description.